Hi students, I'm Praveen Sebastian Paul. In this lecture, we are discussing how to develop a data flow for different systems. So as we discussed in the previous lecture, the DFD or data flow diagram is a graphical representation of a system that shows the input to the system, the processing upon the input, the output of the system, as well as the internal data stores. The DFDs illustrate the series of transformations or computations performed on the objects or the system and the external controls and objects that affect the transformation. The four main parts of DFDs are process, data flows, actors, and data stores, and it also contains constraints as well as control flow. So my students, in this lecture we are discussing how to create or how to generate a data flow diagram using these different parts. In order to develop the DFD model of a system, a hierarchy of DFDs are constructed. The top level DFD comprises of a single process and the actors interacting with it. At each successive lower level, further details are gradually included. A process is decomposed into subprocesses. The data flows among the subprocesses are identified. The control flows are determined and the data stores are defined. While decomposing a process, the data flow into or out of the process should match the data flow at the next level of the DFD. For example, let us consider a software system, wholesaler software, that automates the transaction of a wholesale shop. The shop sells in bulk and has a clientele comprising of merchants and retail shop owners. Each customer is asked to register with his particulars and is given a unique customer code that is known as C code. Once a sale is done, the shop registers its details and sends the goods for dispatch. Each year, the shop distributes Christmas gift or some gifts to its customer, which comprises of a silver coin or a gold coin depending upon the total sales and the decision of the proprietor. The functional model for the wholesale software is as follows. The figure shows a top-level DFD and it shows the software as a single process and the actors that interact with it. The actors in the system are customer, salesperson, and the proprietor or owner. So as we seen, the customer, salespersons, and proprietors are actors. Therefore, these actors are represented by rectangular boxes and the process or the software is represented in a elliptical manner. And these are connected by different connectors. In the next level DFD, as shown in this figure, the major processes of the system are identified, the data stores are defined, and the interaction of the process with the actors and the data stores are established. In the system, three processes can be identified, which are register customer, process sale, and ascertain gift. The data stores that should be required are customer details, sales detail, as well as gift details. So as we seen in this figure, we can see three different processes. The three processes are customer registration, process sale, and ascertain gift. And we can see three different data structures or database or data stores. They are gift details, customer details, and sales details. And we can see three different persons or actors associated with this. These actors are customer, salesperson, and proprietors, which are represented in rectangles. So as we see in here, the actors are represented by rectangles, the processes are rectangle by ellipse, as well as the data stores are represented by two parallel lines. So in the next figure, it shows the details of process register customer. There are three processes in it, that is verify the details, generate the customer code, that is generate the C code, and update the customer details. When the details of the customer are entered, they are verified. If the data is correct, customer code is generated and the data store customer detail is updated. So here in this figure we can see three different processes. Those processes are represented in ellipse. Those processes are verify details, generate customer code and update the customer details. And we can see a data structure or a data store where the customer details are stored. Here in this figure we can also see a decision making statements or constraints which are represented by dotted lines. In the next set of figure, the expansion of the process a certain gift is expanded. It has two processes in it. Find the total sale and decide the type of gift coin. The find total sale process computes the yearly total sale corresponding to each customer and records the data. Taking this record and the decision of the proprietor as input, the gift coins are allotted through decide type of gift coin process. So here we can see two different processes which are represented in the elliptical shape. We can see different data flows and there is a data store associated with this figure. So my dear students, this is how we are representing a data flow diagram for a system or a different solution. So my dear students, hope you had understood this topic. So my dear students, next we are going to discuss about the advantages and disadvantages of data flow diagrams. Firstly, we are discussing the advantages of DFD. One of the advantages, DFDs depict the boundary of a system and hence are helpful in portraying the relationship between the external objects and the processes within the system. Secondly, they help the user to have a knowledge about the system. Thirdly, the graphical representation serves as a blueprint for the programmer to develop a system. And fourthly, DFDs provide detailed information about the system process. And finally, DFDs are used as a part of the system documentation. So these are the major advantages relating with the data flow diagrams. When we come to the disadvantages, DFDs take a long time to create, which may not be feasible for practical purposes. Secondly, DFDs do not provide any information about the time-dependent behavior. That is, they do not specify when the transformations are done. Thirdly, DFDs do not throw any light on the frequency of computation or the reasons for computation. Fourthly, the preparation of DFD is a complex process that needs considerable expertise. Also, it is difficult for a non-technical person to understand. And finally, the method of preparation is subjective and leaves ample scope to be imprecise. So my dear students, these are the major advantages and disadvantages of data flow diagrams. So my dear students, as we discussed, the data flow diagrams are graphical representations of different processes. So my dear students, hope you had understood this topic. So dear students, kindly go through this assignment question. The first question is, write about how to develop a data flow diagram. Secondly, compare the advantages and disadvantages of data flow diagram. So my dear students, in the upcoming lecture, we will discuss another example for a data flow diagram. So see you soon. Until then, goodbye. Thank you and all the best.